Hello and welcome to the official YouTube channel of Microbial Food Safety and Spoilage Lab. In today's video, we will be looking at low water activity foods and the problems faced by these food industries during cleaning and sanitation. Let us first get introduced with low water activity foods. Low water activity food and food ingredients are either naturally low in moisture or they are produced from high water activity foods that are dried at a later stage. The major safety principle here is the reduction of the amount of water available for microbial growth. As per the FDA guidelines, foods with water activity less than 0.85 are referred to as low water activity foods. Now, this includes a wide variety of food products that range from cereal, chocolate and cocoa powders, dried fruits, flours, infant formula, different spices and herbs, grains, pasta, protein powder, milk powders, peanut butter, and oils, and many more. So, this basic introduction tells us that low water activity foods cast a wide net in the consumer market. Although low water activity foods can control the growth of foodborne pathogens, there are some major food safety concerns. Microorganisms, including those capable of causing human disease, can survive these products. Once in a desiccated stage, metabolism of these organisms is greatly reduced, that is, the growth does not occur, but vegetative cells and spores may remain viable for several months or even years. Therefore, effective preventive control step during and after production is necessary to prevent any food safety risks that can occur during the production of these low water activity foods. Now, the problem area in these low water activity food environments is that during the processing of these foods, there are significant risks of post-process cross-contamination. The source of this cross-contamination could be the food contact surfaces and or the food processing environments. And under these conditions, sanitation is the primary barrier against these post-processing environmental contamination. However, sanitation in low water activity food processing environment is challenging due to exclusion of water from the systems, as the introduction of water during the sanitation processes will support microbial growth and can form harborage sites for constant microbial growth and can lead to further food product contamination. Along with the microbial part, there are several processing equipments that cannot tolerate exposure to moisture, such as chocolate molds as well as candy molds. Sanitation preventive control have been used by various food industries to prevent against these microbial food safety risks. However, exclusion of water leads to a limited number of available cleaning and sanitation processes for low water activity environments. Also, these available processes pose their unique limitation. For example, processes such as air impingement or vacuum-based systems, they can lead to aerosolization of food as well as contamination. The alcohol-based sanitizer, although effective, are highly flammable. The hot oil flushes that are used by various food industries such as peanut butter or nut butter industries are inefficient and non-universal for different food processing surfaces. Product push-through is another method which is inefficient and also non-universal. Scraping and brushing is a cleaning technique used by the industry. However, this is also inefficient and non-universal for various food contact surfaces. Cleaning out of place employed by various food industries has its own disassembly flaws, and reintroduction of contamination is possible during the assembly of the equipment. Dry ice is another method used by the industry. However, this process is really costly and can be hazardous to the employee performing the sanitation duties. Therefore, based on these flaws, it is sufficient to say that active research in developing new sanitation strategies and processes is necessary for low water activity food environments. After a thorough review of the pre-existing limitation, we are introducing superheated steam as a novel sanitation technology for these low water activity food and food environments. Superheated steam is a form of steam which has been heated to increase its temperature over the saturation point at a given pressure. Superheated steam is a novel sanitation technique that can be used to inactivate microorganisms in low water activity environments without introduction of any moisture. The process produces high temperature steam that can range from 100 to 400 degrees Celsius and can easily penetrate different processing surfaces, crevices, and bacterial biofilms. The high temperature steam inactivates microbial targets by denaturing their cellular proteins. When superheated steam contacts a food contact material, Its sensible heat is used to heat that surface. High temperature and low moisture content used during superheated steam generation prevents any condensation on the food processing surface. In the next video, we will go into detail for the functions and principle of superheated steam. Please subscribe to our channel for more content related to food safety and spoilage. You can also visit our lab's website linked in the bio for more research updates related to the microbial food safety and spoilage lab.